me is, is Lichtenthäler. And the paper is evaluating native software called Clounaq.
Correct. Okay, thank you for the introduction. Yeah, it's hard to pronounce because that's the name I invented. That's the name for the tool I invented for the tool that I'm going to present to you. So therefore, I would call it Clounaq, but I also accept other pronunciations. Thank you. All right. So maybe before, going to so that you know what is this all about. The thing that I was working with is this term cloud native, where I want to bring some more structure basically into in the end. So I read about this term myself and read a little bit about it, and it found it to be a very complex topic, and different people think differently about it or mean different things when they talk about software that is cloud native. So it covers many aspects, and if you have a look into the literature and let's take some examples, you find different statements, different definitions about it. And to have a look at some examples which aspects are covered are, for example, that it's a lot about the infrastructure where your services run. It's about how you deal with the applications that you can, for example, upgrade and test them seamlessly without interrupting production. So it's also about how you set up your system so that you can introduce updates. It's about whether your components are stateless or stateful, so you have to consider where to put your data and which services only process data. And another statement is that you use microservices, therefore you also need to think about the business capabilities that you want to implement and how you design your services according to them. And in the end also the communication, how you set up your services so that you use well-defined APIs, how they communicate. So you have all these different aspects, which infrastructure you use, how where you put your state, how you design it according to business capabilities, and how you let them communicate. And therefore, I wanted to bring some structure to this so that you better understand what cloud native is all about. And the kind of theoretical aspect covering this is that we build a quality model, which takes the quality aspects that you probably all know, things like reliability, maintainability, and so on, and assign all these different aspects that are talked about when talking about cloud native to different quality aspects. So that in the end, you have a quality model with so-called product factors, which cover application characteristics and quality aspects, and you define impact relationships, meaning that if this characteristic is present in a system, then this has a positive or negative impact on some quality aspect. So we have this quality model for cloud native application characteristics as the theoretical foundation, and now we want to actually be able to use it. So therefore, if we think about an actual application that we want to evaluate according to this quality model, then we could, of course, have a look at the runtime view, but here our focus is supposed to be on this design time view, that you can more flexibly think about how to design your application, how to build your architecture, and evaluate it according to the quality model. And therefore, we want to have an architectural model of our system, which is based on certain entities which represent your actual application, but on a more abstract level, on a level specific to the quality model that we want to consider. And the combination are then here specifically measures and evaluations, that you want to be able to specify measures based on your architecture, which enable you to quantitatively evaluate whether certain characteristics are present in a system or not. And that's basically, the whole approach, which I call Clounaq, for which I then also built a tool to use it practically. And that is what I want to show you and what we want to evaluate, or what we evaluated in this paper based on some use cases. So therefore the tool covers as a one core aspect the ability to model your system with the entities for the quality model, and it allows you to do this devaluation that you can automatically calculate these measures and use them to evaluate the product factors and the quality aspects. So that is the guiding research question: how well does this work? And the approach we use is, in the first place, identify some applications that fit into this context that we can use as use cases, extract key characteristics, so what is special about them, how does that fit to characteristics that you associate with cloud-native applications, and then create the models with the tool and evaluate these architectures. So the modeling part is a manual step, but then we can do the evaluation automatically because it's all defined on these models. So therefore, in the end, we compare these two aspects. What did we know about these applications from their descriptions from the literature, and what does the tool say about these applications? So therefore, we chose 3 sample applications which you might know because they have been used in literature a lot actually, which also helped because they were more or less well documented. And these are some screenshots of the models, but we will have a more detailed look. That's what I want. I think it's more easy to have a quick live demo on how it's worked. You can also have a look at the tool yourself, but I have to warn you that it's not optimized for cell phones, so it would be better to use a desktop. You will see in a minute why. So I have prepared these models. So this is the tooling where you have the ability to model your software architectures. In this tab, as you see, you have these entities which are specific to the quality models. And here, for example, is the T-Store application, and then you can have a look at the different entities. For example, this service here, which is a web UI service, and you have some additional properties that more specifically define characteristics of this component. And you can have, for example, other entities are here, the endpoints of an application, which in this case is a get endpoint, which serves you the product page. And another thing I wanted to show you, because this is also then for the evaluation, you can model request traces, meaning that if you do a certain action in your application, then you can model how it works in the whole system. So that, for example, if you invoke this show product request, this service here queries endpoints of other service and uses certain data aggregates. For example, here a product, which is a representation of this product data aggregate, and to serve that request in the end. So for example, here you can also define how this endpoint show product uses certain data aggregates. For example, in this case, it uses the product data aggregate, and it just uses this by querying it from the other services. And then, if you have modeled your architecture, you can then go on the evaluation tab and, for example, select this T-Store application, and it will use the modeled architecture to evaluate these different product factors. And let's stick with the example of how certain data aggregates are used. So, for example, if a data aggregate, think of it of a data object like the product, is queried from the database and used in different services, it would be nice if it caches them so that it doesn't always have to go to the database in the end to be more to be more efficient, to have a better response time. Then that is something here you could evaluate because overall they're only cached to some extent, so you could it has a certain impact, but it could be maybe improved. So that just as an illustration how you can use it. One more thing, and we can also evaluate the different request traces, for example, to have a more closer look on more detailed aspect, like this product page request. You request trace that I showed you, where you can also have a look for this specific request trace, there is actually more caching than considering the system here as a whole. So that, to give you a quick impression how it works, and for the results, as I said, we use these 3 different applications, and we're able to find out, or then have a look at the different characteristics. For example, one thing you can evaluate is that considered asynchronous communication, only the Lakeside Mutual application uses that, and you can quantify it based on the architectural model of the system. Other examples are whether if you have a configuration management, where you store configuration values. For example, for the T-Store application, it's isolated from the components, but for example not stored in a specific configuration service, so that you could update the configuration at runtime, while the Pet Clinic application, for example, does that. And some further examples. Also for the caching, you see that these applications uses them, but for example Lakeside Mutual doesn't, or also how services find other services, which technologies are used there, and to what extent this is implemented in applications. You can evaluate based on architectural measures here. So overall, to come to a conclusion, key characteristics are covered, but certain aspects which are, for example, the Lakeside Mutual application, which was used to showcase characteristics of API patterns. Some more detailed aspects are not covered, and also the reported values here are always on the level of systems as a whole, but as I showed you, for example, with the request trace, it's also possible to have a closer look further down on certain entities, like a single service or a certain request trace. So overall, it's working nicely. There are some aspects, as you have seen in the demo, it can grow very big when the architectures grow large, so it might be there might be certain aspects that you could improve regarding the ease of use of the tooling. The modeling itself also is a manual process. Theoretically, you could think about how to automate it from source code or deployment descriptions, but because of the large technological heterogeneity of cloud applications, we decided to stick to the manual approach first, to focus on these quality evaluations. And also what I've shown you how these evaluations are done would need further validation, because right now it's mostly based on what we found in the literature, and for example defining metrics with values between 0 and 1 to get to the point that you can say, okay, 1 is this product factor is high, 0 is low, and therefore the impact is high or low. But to have a more more meaningful evaluations there, you would have to try this out further with use cases. And also the applications considered in this use case only had certain characteristics. So therefore, with the tool, the breadth of this topic of cloud native is covered, and also the evaluation on different layers is possible, but in the end, this is intended as an informational basis that you can have a look at your architecture, design it, play around with it, but in the end, decisions need to be made according to the specific use case that you want to implement. So I hope I could give you a good overview and how to use the tool, and that's about it. Thank you.
Maybe we switch some short question. No?